In mathematics, convolution is a mathematical operation on two functions. It produces a third function that is typically viewed as a modified version of one of the original functions, giving the integral of the pointwise multiplication of the two functions as a function of the amount that one of the original functions is. Translated. Convolution is similar to cross-correlation. It has applications that include probability, statistics, computer vision, natural language processing, image and signal processing, engineering, and differential equations. The convolution can be defined for functions on groups other than Euclidean space. For example, periodic functions, such as the discrete time Fourier transform, can be defined on a circle and convolved by periodic convolution. A discrete convolution can be defined for functions on the set of integers. Generalizations of convolution have applications in the field of numerical analysis and numerical linear algebra, and in the design and implementation of finite impulse response filters in signal processing. Computing the inverse of the convolution operation is known as deconvolution. Visual explanation. Applications. Convolution and related operations are found in many applications in science, engineering and mathematics. In image processing. In digital image processing, convolutional filtering plays an important role in many important algorithms in edge detection and related processes. In optics, an out-of-focus photograph is a convolution of the sharp image with a lens function. The photographic term for this is bokeh. In image processing applications such as adding blurring. In digital data processing. In analytical chemistry, Savitzky-Golay smoothing filters are used for the analysis of spectroscopic data. They can improve signal-to-noise ratio with minimal distortion of the spectra. In statistics, a weighted moving average is a convolution. In acoustics, reverberation is the convolution of the original sound with echoes from objects surrounding the sound source. In digital signal processing, convolution is used to map the impulse response of a real room on a digital audio signal. In electronic music, convolution is the imposition of a spectral arrhythmic structure on a sound. Often this envelope structure is taken from another sound. The convolution of two signals is the filtering of one through the other. In electrical engineering, the convolution of one function with a second function gives the output of a linear time invariant system. At any given moment, the output is an accumulated effect of all the prior values of the input function, with the most recent values typically having the most influence. The impulse response function provides that factor as a function of the elapsed time since each input value occurred. In physics, wherever there is a linear system with a superposition principle, a convolution operation makes an appearance. For instance, in spectroscopy, line broadening due to the Doppler effect on its own gives a Gaussian spectral line shape, and collision broadening alone gives a Lorentzian line shape. When both effects are operative, the line shape is a convolution of Gaussian and Lorentzian, a Voigt function. In time-resolved fluorescence spectroscopy, the excitation signal can be treated as a chain of delta pulses, and the measured fluorescence is a sum of exponential decays from each delta pulse. In computational fluid dynamics, the large eddy simulation turbulence model uses the convolution operation to lower the range of length scales necessary in computation, thereby reducing computational cost. In probability theory, the probability distribution of the sum of two independent random variables is the convolution of their individual distributions. In kernel density estimation, a distribution is estimated from sample points by convolution with a kernel, such as an isotropic Gaussian. In radiotherapy treatment planning systems, most part of all modern codes of calculation applies a convolution superposition algorithm. Convolutional neural networks supply multiple cascaded convolution kernels with applications in machine vision and artificial intelligence.